This video shows an S-gauge automatic switching block in operation. It basically continues from video 658, which shows the S-gauge automatic block, a single track unit, and video 659, which shows the automatic passing siding, which operated 2 trains. This combines the functionality of those 2 units into one system that alternates 3 trains. The large-scale video V637 demonstrates the same principles in G-scale, and also large-scale video 636. The links for all this stuff are on the AutoControls-dot-org video page. We built the Model 163 automatic switching block in large scale in 1992 using essentially stock LGB components, except for rheostats and knife switches. Now we're trying the same thing in S-gauge. The principles of this type of unit operate in any scale. The trick is just to keep the hardware working reasonably reliably. From further up, where we were looking a minute ago was underneath this platform. You can see the loop basically stretches around the perimeter of this barn. The basic principle of this system is it holds 2 trains on the sidings and lets a 3rd train get about 2/3 of the way around or further around the loop. Then it starts a train out of a siding. The magnets on the engines or cars code reed switches, which activate relays. In this case, the relay is an automatic, is a Railroad Concepts switching interface module, which is located right to the left of the red cardboard there. And to operate as American Flyer switches, we're using Automotive relays. The details of this were covered all in the previous video, number 659. You can see back in the rear of the layout there's a piece of green cardboard. That's where the go reed switch is. When that train that's out on the main line reaches that piece of green cardboard, it'll set the block to green. Right about now, you can see the block turn from red to green. Now the train exiting the block will set the block back to red, so it'll trap the train coming into the yard. That'll sit there and wait till the cycle continues. When you're using large-scale stuff, you can use a reed switch to drive the turnout directly. An LGB large-scale turnout requires about 1/4 of an amp, but an S-gauge turnout, they all use twin-coil switch machines or something similar, and they require 3 amps to 5 amps, which is too much. It'll blow a reed switch out. The LGB actually uses a small DC motor, but with these S-gauge switches and the twin-coil switch machines, it requires too much current. So that's why we're using Automotive relays in the system to operate the turnouts. It would be great if we had a more efficient switching machine in S-gauge, but that's probably not going to happen. I don't think there's enough interest in this stuff for it to ever cause a redesign of the switch machines. As far as reliability of this system, in theory, it's perfect. Those 2 trains will sit there and wait until that 3rd train reaches that green cardboard. It'll set the block to green. The train will pull out, vacating a siding. The train that's coming in from the rear will pull in on the now red siding and stop. As I said, it's perfect in theory. The challenge in the real world is keeping everything working right, keeping the switches throwing properly, preventing derailments, uncouplings, and engine stalling. Some people have asked, why would you want to do this? I guess there's basically 3 advantages. It allows 3 different trains to be displayed on a single loop. If you're doing this at a public display, it's just something different. You have trains stopping and starting. Plus, it kind of allows your engines to rest because each individual engine is only running approximately a third of the time. Most of the time, 2 of the engines are sitting. We've been Again, just reviewing how this thing works. There's a reed switch under here. That's where that wire goes to reed switch, which operates as Railroad Concepts switching interface module. This is the reed switch that sets the red, which is the state it's in now. Back at the rear, back there where that green cardboard is where it sets it to green. So that operates the block part, the red to green part. Turnouts are controlled by, I think they're visible here. This is the reed switch in the one leg of the siding, and this reed switch in the other leg of the siding. These reed switches activate these automotive relays, which in turn activate the flyer switches, which with the controls button in the right setting will switch power to the 2 legs. So this turnout, when it's straight like it is now, this side is turned off. And when it's curved, this side is turned off. So the turnout controls which of these 2 trains is going to get the power to pull out, but neither of them will pull out until the block goes to green. So that's the basic principle of operation of this thing. The stop block is from this gap here back to these gaps here. So when the block is red, as it is now, this is all dead and nothing up here will move. When it goes green, whichever of the sidings has the power that's routed from the American Flyer switch, that train will get power to pull out. Then the slowdown blocks, which are from here, they go from here back behind the switch to this gap in the track here. The idea being a train comes in and hits the slowdown block, it'll slow it down going a little bit through the switches, and this is very helpful in large scale. In S scale, I haven't actually used a slow down that much, but it is available. Okay, we get the camera back behind the rear switch now.
Just like Mark.
One thing you got to do on this layout is make sure the train leaving the siding gets out of the siding before the one coming in behind it goes over the reed switch, or else it trips the turnout and the turnout flows underneath the caboose and you got a derailment. On a larger loop, you would just move the contact further back away from this switch. But on a small loop, there's not a lot of space here. Hear those switches throw. The American Flyer caboose just barely got out of the switch in time. You can see with 3 trains, they rotate tracks. Each engine, when it comes around, will be on a different siding. In other words, the Atlantic was on the inside track a minute ago. Now it came around this time, it's on the outside track because you have an odd number of trains using 2 sidings, so the trains are continually rotating sidings. If you just run 2 trains, then each train will always use the same siding until you deliberately change the system. Or if you ran 4 trains, which you could do on a larger loop by keeping 2 on the main line, again, with an even number of trains, each train would use the same siding. Okay, now I've moved the camera back again. I'm as far back as I can go. I'm right up against the wall of the building, but you can see the green cardboard here in the bottom of the picture. That's where the reed switch is under the track that sets that block to green. So the Atlantic just went over that reed switch and set the block to green, which is causing the 283 to pull out of the siding. Now the Atlantic ran over the reed switches up in the siding, which caused the turnouts to float us straight. Now if you can see the light up there when the 283 gets right here to the cardboard, the magnet will go over the reed switch, set the block to green, and the train on the siding will start to pull out. When it exits the siding, it sets a block to red to stop the train behind it.
I'm wondering if you're not, maybe like a passenger plate, maybe that. I have one on the other one too.
Is that one sticking too?
Yeah, that was the off one. That one's going to be required.
Okay, again, the K4 is approaching the green track contact, set the block to green, which powers up the siding. The Atlantic's pulling out of the siding. It just set the block to red. Now the K4 is pulling into the dead siding, and it'll stop and wait.